Nice, nice. It's gonna be interesting. All right, so I guess I'll just kick it off. Just start. Anything I need to wait for? Nope. All right. Cool. Hello, everyone in the crowd. Uh, Thank you for showing up today. We're about to begin the workshop on how to turn a Web2 asset into a Web3 game. My name is Jay Albert. I am a project manager from the Godwoken blockchain. It's a blockchain focused on gaming and creatives. And today we're going to go over how to turn a Web2 game into a Web3 game. There's going to be a bunch of steps involved. So first, let's make sure we're all on the same page. We'll be setting up some storage with a NFT storage Unity SDK, downloading a free asset that you can use in Unity, setting up your NFT storage account, configuring that scene so that you can publish anything you save onto NFT.storage. We'll be creating a wallet from scratch, acquiring PCKB, which is our native token. We'll be launching a smart contract, putting together a mint function within Unity. We'll build your game, and then we'll preview your NFTs. So there's a lot that we're going to cover. And because of that, I put together this guide for everyone to follow along with. So if you're building live with us, make sure you scan this guide. It's going to be the same guide I'm following along with throughout the demo. So you'll see me kind of flip back and forth between the demo, between Unity, and the different assets we'll have to download. So I see a couple of people downloading it now. I'll give you a minute. And I put this together because I've been part of several different workshops, and sometimes people fall behind. Sometimes you miss the word that the speaker said. So I figured I'd give you every single step you need to do this, even if you've missed it. I think we have one more person scanning. All set? All right. So let's jump into how to turn this Web2 asset into a Web3 game. Testing, testing. Hello? Hello? Okay. Yeah, I think you can hear me better now. So if you follow that link, then you'll open up this guide to install Unity. By now, you should have had Unity installed because it may take a bit of time. If you have a newer version of Unity, then you're going to have to update it with one of our packages in the next step, so look out for that step. So first, we want to install our NFT storage Unity SDK. It's an SDK that we put together, and this is going to interact between Unity and NFT.storage. So if you click on the link here, you can navigate to the actual files, click on code, download zip, and unzip it. I've already done this on my side, so instead, I'm going to go straight to the Unity Hub. I have it download here in the section that I put together for this tutorial. Let's extract it here. So it's going to be a zip file, extractor zip file. And once that's ready, we're going to want to open that file in Unity Hub. So go over to your Unity Hub, go to Open, Add Project from Disk, and we're going to add in that SDK, so that's our starting ground. So we don't have to kind of put together scripts from the beginning. We'll have this as our basis. Now, what's in this project is basically a script that's going to allow the user to take a screenshot of what they're seeing. So think about like maybe Pokemon where they want to capture what's going on, or a race car where you want to capture a high score. You'll be able to capture that event and mint it as an NFT. So I have it here. I have the proper version, but if not, you're going to have to follow this next step where you upload the package. So as it's loading, it's going to take a minute or two. I want to go over the Unity Hub for those who haven't seen it, who haven't built a game ever before. Here you'll have your projects listed. Then you'll have different versions of Unity, so that if you release an old version of Unity, even if there's updates that maybe make your scripts deprecated, you can still use that old version, still run it without running into any issues. So I have two different versions here. We have this Learn section where there's a bunch of tutorials on Unity, anything from augmented reality to making 3D objects, 2D objects, animations, music, anything that you think of that's involved in a game, you can find lessons on here in Unity. Lastly, we have this community section where you can find free assets that either you or others can publish. We have some newsletters, some blogs on updates for Unity, a couple of forums where you can see the most recent conversations going on in Unity. You can ask your own questions. A section for you to publish your games, so once you're done, you can find your audience. And Unity Pulse, where you can reach out to the team, contact them, provide them some feedback on your experience. So, it's still importing, give it a minute. And it's starting to load up Unity. So Unity is great for indie game designers. Anyone can use it. It's a free asset. You can build your games out in here, export it to several different platforms, from WebGL to even Facebook games, PS5, Xbox. So it's a great way to get started in building and to publish your games. Sorry, it's taking a bit longer than I hoped. If you have a newer version of Unity, now's your chance to go into your packages and add in your the missing files. There's additional instructions that I've included in the documents. And now we have our Unity open. So really quick, if you've never seen Unity, again, here's a brief overview. Everything on your left-hand column are your assets in your game. So think about your assets as what's being involved in your scene. Think of a movie scene or a game scene. If it's a race car, then you're going to have maybe some cars, you're going to have a road, you're going to have some background scenery. So this is where you can put all of your assets that are going to be included in your scene right now. Over here you have a list of different assets. This is where everything is stored so that you can pick and choose what assets you'd like to use. And then on the right-hand panel, it has the details for each one of the assets. So see, we've picked on the main camera. It shows that we can move our camera anywhere we want, make some changes to how it's configured, add some scripts to it, some audio, and this is essentially our Unity interface. So first thing we're going to do is add in our free asset. So we've opened up with our camera capture. Now we want to download the asset that we're going to use in our game. So I'll go back to our guide now. And I provided a link here so that you can go to the free asset. It's going to be a simple drawing asset just to convey the idea of what's possible. So this is what it'll look like. Once you start the game, you'll be able to draw whatever you want. And then the next challenging piece of this is making sure that that drawing is minted on our blockchain. So let's open this in Unity. It'll open up your package manager. So this is where you have several different things installed. If you're maybe messing around with virtual reality, you'll have some packages there. In this case, there's even blockchain SDKs. Really anything you download from the Unity Asset Store, you'll find in this section. This is the game that we're going to work on right now. So let's import this. It's free draw. Import. These are all the assets that are going to come with it. So it's a bit of a preview. Click imports, and it'll save all the files in your storage. So now that we have our Unity assets, let's set up our storage. So we have the game that we're going to be drawing. We have the NFT storage SDK that's going to be able to communicate with our storage, but now we have to set up our actual storage. So as many of you know, it's pretty common in the space to use IPFS to save your files, especially for NFTs. These are some old files here, so let me just delete this real quick. But when you first log on to NFT storage, you can sign on with your GitHub or your email. And the first thing you're going to need to do is create an API key. So if you go to this section here, API keys at the top, I've already created one that I use for most of my demos, but you can create a new key here. Just fill out the name and create. That's going to allow NFT.storage to track you as a user to make sure there's not someone else using your key and creating a bunch of assets. So we have our key set up. Next, after our key, we have to actually import that key, copy and paste that key into our NFT storage SDK so that our Unity game knows where to send information to. So let's go over here, copy this, navigate back to Unity. So we're going to go into our NFT storage, examples. Give me one sec. NFT storage scripts, classes, constants, and our keys. So here's really simple, doesn't have any information besides what is your key. You paste in your API key here, save, and close that out. So now Unity knows where to communicate the information once you start storing your images. So next up, we have to configure our draw assets so that we can draw and then mint. So if you notice when you first looked at the game online over here, it just has an option for you to draw, but there's no way for you to take that information and mint it on a blockchain. So what we're going to have to do is create some buttons so that we can press them to mint and so that we can start transferring over information. So first we want to open up that game. We'll use that as a basis for our project. This is what I was mentioning earlier. This is our scene. Typically in this middle screen, you'll see what's going on in your scene. Right now it's a bit hard to understand what's going on. But if you zoom out, you'll see that it's a screen and we have some controls on the side. You can use this on the top right to kind of switch your angles that you're viewing the asset in. But since it's a 2D game and a 2D screen, I just go over here to this 2D button and it'll give you just kind of a flat view where you can move this around. So this is what our game looks like. As I mentioned, it doesn't have a button. It doesn't have any way for us to mint anything. So that's what we'll have to start working on. First thing is let's click on this canvas. This is where we're going to put everything in our game. Right click, UI, and then button text mesh pro. All right, so let's name this mint button. So as I mentioned earlier, once you click on your objects, you'll see on the right-hand side, there's a bunch of details on what you can do with that object. We can switch the position. Let's say make this 10 or 100. Now it's moving to the right. And this section here is saying, what do we want to move that object relative to? So I want to make sure that whenever anyone opens this game, the buttons are roughly in the bottom left-hand corner. So let's switch this to bottom left-hand corner and say, all right, I want it to be maybe 100x away from the left-hand side of the screen. And then from the Y position, let's say I want maybe 40. So no matter what screen pops up, it'll be roughly these dimensions, and it'll pop up relative to the bottom of the screen. So there's our mint button. If we want to add a bit more detail, we can click on the text here. There's a bit of a drop down after the button. We see button here, and we can change this text input to mint. And now this says mint here. So when we start to save our file to IPFS, we're going to want to grab that ID, send it back and forth, and we're going to have an input field for us to transfer that information. So go to UI, go to input field, text mesh pro, and we're going to do the same thing. We're going to anchor this to the bottom left corner, and we're going to move it next to our mint button. So this is, let's say, 400. 300 is better. We want it to be around the same height, so let's put about 40. All right, so now we have our button, and we have an input field to transfer information. Next, we want to work on our network manager. So we're going to be pressing buttons. We're going to be drawing our assets, and we want to make sure that that's communicated over to the network to NFT.storage. So we're going to go click here, create an empty object, and name it Network Manager. And if you're following along, we should be kind of on area 7. So you have all of these notes. If you're a little bit behind or you missed something, you can follow along. All right, so we have our Network Manager. Now what we're going to want to do is add the camera capture onto our Network Manager. So we can find that in NFT storage, example scripts, NFT storage, example scripts, and our camera capture. What we're going to want to do is drag and drop it to say, all right, what we're communicating over to the network is what we're capturing with our camera. And we want it to be initiated by a button. We want an input field so that we can transfer that information. And we also want to set some metadata so that we know what is going to be uploaded to IPFS, what data is that going to contain. So this is the script that comes with our Unity NFT storage SDK. Once you drop it into here, it's going to ask you what buttons are you referencing, what input field are you referencing, and that's what we've just created. So you can just grab your assets from the left-hand side, drag them over. So we're going to put our mint button on our button. We're going to put our input field on input field. And for set metadata, that's actually a script here that we've pre-prepared for you. So you add that to the object, and then you drag and drop that over to set metadata. So now once we start to play the game, we start drawing an asset. We can draw whatever we want, press a mint button, and it'll send that information over to our NFT storage. So now this is where we have to kind of mess with our scripts a bit, and where I'll go back to our tutorial. So open up this set metadata. We're going to want to manipulate this callback on upload. There's tons of different things you can upload, but we want to specify that we're uploading these images. So if I go over to our tutorial, let's see, we've skipped through all this. We've done this already. We're looking for this here, number 10 under configure Unity to draw a mint. So we can just copy and paste this over. This is constructing the path for our NFTs. And this is going to upload it to NFT storage. All right, so now we want to make sure that we set up our gateway so that when we're saving the file, there's a URL that we can access to actually view the image. So we can go to nft.storage. Go over to our scripts, classes, NFT metadata. And here you can use tons of different public gateways. You can find this online, search for them on how to store your files properly. But for here, we've set up this one piece here that I'll copy. So we're going to be using Cloudflare to save our files. So you can just replace this here. If you leave it as is, it won't work. It'll throw some errors at you because that's not a proper gateway. So let's save that. And lastly, we need to manage our events. So far, we've set up our NFT storage. We've set up the basic view of our game. We set up some buttons to say, all right, I'm done with my drawing. I want to save this file onto nft.storage. But we don't really have a way for our game to communicate amongst itself to say, all right, what's happening within the game? What do I do next? So to do that, we have to create a new file, and it's called our event manager. So create C# script and our event manager. Here I've also included the script because at another event I tried to hard code all of this live, and that did not go too well. So I provided the scripts in advance. Let's close this out. Let's open that file that we've just created, our event manager. Let's get rid of all this and paste in our new events. So this is saying once a new image is uploaded, this is uploading the new image, uploading the metadata, and the NFTs. All right, so as of right now, we have everything that we need to actually start drawing and for this to be saved on IPFS. So let's save this. Let's minimize the script for now. Every time you edit your scripts, the compiler is going to recompile the scripts to make sure it works, there's no errors. As long as there's no kind of anything jumping out at you, you can clear your console, you're good to run. Sometimes that'll give you warnings saying maybe you're using an old script or old way of doing this. But it looks like we don't have any issues now. So whenever you want to test out your game, you can go to this button here and it'll start running everything you've put together. So this is the game. It's loading up right now. Let's say, a green pen. And let's write build. All right, that's a little bit skinny. Let's make it a bit bigger. All right, it's terrible to try to draw with a mouse pad, but that's my build. So now when we press Mint, it's going to start uploading this file to our IPFS account, and we'll be able to see the metadata along with the actual file there. So let me go back to IPFS. Go to your files on nft.storage. Let's see, the 26, 11, 25, that seems to be right. So these are the two newest files. Everything else is just old data. Let's view our URL. And we saved our image to nft.storage. So now we're going to use this to actually mint on our blockchain, and we'll be going into those next steps. So I'm sure many of you are super familiar with MetaMask, probably have a ton set up, but I'd like for this to be a tutorial for beginners. So we'll briefly go through that, kind of just run through that real quick, set up our network for Godwoken, and then we'll work on our smart contract. So if I go back to our tutorial, you can use MetaMask on several different browsers. I'll start downloading it here. If you're working on anything you're building brand new, I suggest you create a developer wallet specifically for this. You don't want to test with real currencies, with your real wallet, with your real identity. You want something that you can kind of connect to anything, play around, and who cares if they try to rob the funds in there. It's not going to affect you. All right, so I installed MetaMask. For anyone who's not familiar, this is your portal into the blockchain. This is how you view what assets you have, how to access your assets. Let's create a new wallet. You don't have to agree to that. That's if you want to share information with MetaMask. Create your password. This is how you're going to unlock your MetaMask every time you want to use it on your browser. Understand. Let's see. Next, after you press Create Wallet, it's going to tell you to remember a phrase. This will give you a brief video of what you should know about MetaMask. I'm going to skip this, but let's secure my wallet. So it's going to give you 12 words. These 12 words should never be shared with anyone. They should be saved somewhere where no one can access it, because if they find these words, then they can steal your funds, do whatever they want with your money. So I'll open up a text pad and save these words here, because the next screen is going to ask me to verify that I remembered those words. So here it's asking me for the same words. The third word was next. So you retype it here. It's not as much of a risk if you're using a test wallet, so that's exactly why I'm doing it. And next one is kitchen. All right, confirm. We created our wallet. We have MetaMask installed. It suggests that you pin it so that it's easily accessible. This is what our wallet looks like. It's generally going to be on the Ethereum network by default. So let's go to our pinned. Let's pin this here. And now we can just click on here and access our MetaMask wallet. All right, next step is we want to start minting our assets on Godwoken blockchain. So in order to do that, you'll have to add the network. The great thing about Godwoken is that it's EVM compatible. So any tools that you use for Ethereum, you can use on the Godwoken blockchain and get all the benefits of being on Godwoken. So in order to add a network to your wallet, click on the network here. It says Ethereum wallet. Let's add a network. It's going to come pre-populated with some of the more common networks. Godwoken's been around for maybe 6 months now, so we're not on this list yet, but we're aiming to get there. Let's add a network manually. So now the question is, where do you get these details? If you go to our Godwoken website, look at our documents, you can find our network details. They'll look like this. So let me open this link to show you our documents. There's going to be a testnet and a mainnet. So testnet is for you to play around with. You can get some fake money, publish some contracts without any consequences. Mainnet is when you're ready to publish your work, to go live, to actually have customers. So it's going to ask you for these exact details, so we can just copy and paste this over. Here. Our native token is PCKB. That is from the layer 1 that this is built on top of, which is the Nervos network. And we want to take this URL just because when we want to check our transactions, it's going to be much easier to access if we have this configured. All right, so we save our network, and now we're on the Godwoken testnet network. First thing we'll need to do in order for us to launch smart contracts is acquire some faucet tokens. So if you go back to our docs, click on this faucet, you'll see a screen like this, super simple, press request. It's going to ask you to sign your wallet. Let's sign that, let's connect. And within a second or two, it should give me 10 PCKB. And this is what we'll use to fund our smart contracts. Let's press it again one more time. And we have our PCKB. So this is what we'll use to be processing our transactions. All right, I'm going to close this out. I have tons of windows open, so let's close that, close. Let's keep this NFT.storage for our future drawings. Let's close this and close this. So if you've never written a smart contract before, OpenZeppelin actually created a really awesome tool for you to just kind of click what options you want in your smart contract and have that populate into a script, and then you can use that script to launch your smart contract. Since we're EVM compatible, we can use all the same things that Ethereum's using, as I mentioned. So we can use the same exact tool. All we have to do is reference our network ID, and we're done. So if you've never visited OpenZeppelin, here's a list of a bunch of different contracts you can use. So if you wanted to launch your own token, you can just click ERC20, and you can launch your own currency. Click what functions you want. If you want to be able to mint it, if you want people to be able to burn it. In our case, we're making an NFT, so we're going to switch over to ERC721. Give this a really unique name because we're going to reference this later and make sure this was published on the blockchain. So I'll name this Biddle Week. And the symbol will be BDLW. If you want, you can give your NFTs a unique URL so that they're numbered by that URL, but I'm going to skip that. I want it to make it so that anyone could call this function and it's mintable. We're going to auto increment so you can mint several different NFTs on it. Make it enumerable so that's reflected on chain. And URI storage since we're going to be referencing some storage on NFT.storage. So we clicked everything we want in our contract right here. And as you notice, it just kind of plopped in the scripts that we need so that we can launch our smart contract. Let's open this in Remix. This is an online IDE that you can use to launch your smart contracts. It's a pretty awesome tool. I use it all the time. Here's our contract that it transferred over. You can see it says Biddle Week, BDLW. It has our minting function, how to transfer. So this is our safe mint function. The transfer has some options to burn it. This is the information it's grabbing from our URI storage. It has everything we need right now, so let's compile this. Next, what you're going to need to do is copy this ABI at the bottom. This is what kind of breaks down your contract into binary so that you can communicate between networks. We're going to have to reference this in our script, so open up a notepad and save that for later. It's in a JSON format. We're going to need to also reformat this, so we'll do that in a bit. So we compiled our contract, didn't give us any errors. Of course, because these are tested contracts, we know they work. That's the reason why we use them. So now let's go over to deploying our contract. We want to switch our environment to injected provider. This is going to say, all right, I'm using my MetaMask to launch these contracts to process these transactions. So as soon as I press it, it's going to ask for me to sign in with my wallet. So I make that connection. And now it shows my account here. Great. So I have my contract. I have my wallet connected. Now all I have to do is deploy it. So you click this deploy. It's going to ask you to process the transaction. If we didn't acquire testnet PCKB, it'll tell you insufficient funds here. So that's why that last step was important. We needed money to be able to process our transactions. So let's confirm. Give it a second or two. It'll launch your smart contract. It'll publish it and say, all right, you're good to go. This is on your blockchain. So we have this check, success. We have our transaction hash. Now, if we want to check where that smart contract is on our blockchain, we'll have to take this transaction hash and go over to our Explorer. So at Godwoken, we have an Explorer up. It's GW scan. You can navigate to it in our docs. Paste in the hash here, and this will show you the smart contract that we just launched. You can verify it's yours by checking the wallet. So let's see, my wallet begins with OX5E6. So you can see that here. This was a contract from OX5E6. This is the deployed contract. So this is just a kind of a registering that there was a smart contract deployed. But if you want to look at your actual smart contract, you want to click on deployed contract here. And we're going to be referencing this ID later in our scripts so that Unity knows what smart contract to call to publish images. All right, so we set up our smart contract. We deployed it. Now we have to set up our Godwoken minter. This is what's going to say, hey, I got these images. The person wants to publish it. Send this information over to our smart contract, publish it on the blockchain. So that will do from scratch. I also have some copy and paste pieces here, so it's not entirely from scratch, so I don't want to mess that up, but we'll jump into that now. All right, so here, let's create our empty object, Godwoken minter. And in our projects, go to assets. We're going to create a new script with the same name, Godwoken minter. All right, let's open this script. And this is a little bit more step-by-step so you understand what's going on here. So let's go to our guide again. Here's the first portion of our script. We should be up to set up your Godwoken minter. I'm at number 2. So let's replace all of this and save this. These are some packages that we'll need in order to communicate between all the different applications we're working with. Here is our contract address. So this is actually asking, hey, where do you want me to send this information to? What is the smart contract? Where can I find it? So if we go over to our Godwoken scanner, that's our contract that we want to grab here. Just copy this over. Go back to your script, paste that in. Now this information, if you are using maybe another script or you put it together yourself, you'll have to manually put in your chain network, RPC, and chain ID. That is the same information we used to switch our networks when we were putting together our wallet. That's that was at our docs. So that's right here. The same information you see here, that's what you're going to need to put in your script so that it knows what network is it communicating with. So you're telling it the contract, you're telling it the network, but now you also need to give it the binary information it needs to communicate with that contract. So that's this information here. If you remember earlier, I told you to copy and paste your ABI here. And we need to reformat it to work in this format for Unity. So let's select all of it, press the replace button. And what we're going to be replacing is a double quote with a backslash double quote. Let's replace all. It'll make that change. And now we want to get this all in a single line. So there's a website that we use to do that. Instead of you having to kind of manually subtract lines, do that on your own. Let's see. So that's here. Just paste your text into here. Press remove, replace line breaks, and it'll generate the text for you. Copy that over. Go back to your script and replace this ABI. So now if you decided you wanted to just not change any of this information, use all of the details that are here and try to mint something, you're not actually going to be able to mint your NFTs. And the reason why is because you're not the owner of that smart contract. And when we minted our smart contract, if you take a look at it here, it's actually checking to see, all right, is this person the owner of the smart contract? So no other wallets can actually use this contract to publish. Every contract is going to be unique, so no one could use yours that you put together today. If you wanted to make it accessible to other users, so anyone can mint an NFT from your game, let's say, you would just need to remove this line here. All right, so we have our script here. These are all the details we need to communicate with the network. Now we have to tell it, all right, what do we want to actually communicate? So let's go back to our guide. Let's copy this over here. We're going to say, all right, we want to take whatever account is right now signed up to the game, and we're going to use that information once the game starts. So that's going to be the first check that the game makes. All right, so let's copy and paste these here. Just making this a bit neater. The transfer over from Notion isn't the most seamless. All right, so this is saying once the game starts, I want to see what that person's account is by checking in their player prefs. In Unity, that's essentially checking the session, who's in your game, who's playing right now. We're going to take their account and pass that over to our event manager and see, all right, is this person minting a new NFT? We're going to process a transaction with that. We're going to prompt their wallet. So we need these details to interact with their wallet. Now, besides that, we have the actual mint function. So once we mint, these are the details we'll send over to our smart contract. If you're not sure what details your smart contract needs, you can check the Open Zeppelin website, and it'll have all the details there from your to wallet, the from, any custom contracts you're using, all the details you need for that. All right, so here it's going to format our URI to send that information to our nft.storage so it knows how to save it. We're telling our smart contract that we want to use the safe mint function so that we can mint an NFT using that smart contract. This is just kind of converting data to JSON. And these are just additional scripts we're using to either publish from the Unity WebGL online site or from our editor while we're working on it. All right, so we have everything set up for our God Woken Minter. Let's save that. Let's see if Unity screams at us. All right, so let's see. God Woken Minter, namespace directly, fields or methods. I think I needed to paste it into here, so that was my mistake. Let's grab this, cut here, and that should be good. All right, percent assembly reference. All right, so the next thing we're gonna work on from our minter is our NFT data. All right, so we're gonna have to send over some metadata to the smart contract, and this is what's saying what we want to grab over, what we're sending over to NFT.storage from our game. Sorry, this is actually the helper function we're putting together. That's helping this JSON conversion between the data. So let's look into NFT meta. All right, we're gonna create a new file. Let's name it NFT metadata utils. And here we're going to let it know how to convert the data that it's receiving in metadata from our game over to NFT.storage. So let's save that. This conversion happens in tons of different games when you're communicating between systems, so there's nothing special here. All right, so save all the files. Let's see if that compiles correctly. Let's see, models. Looks like there's an issue with our Godwoken minter on 4.7. Let's take a look at that. Cannot be found using a direct assembly. Let's see if we can still run this. Nope. Give me 1 second to look at our minter. Models NFT storage. Let's see. Let's attach our Godwoken minter script. That's what's going to run because that's going to be found. Just give me 1 moment. I actually built this morning and didn't run into any issues, but you know how it is when you're building in front of people. That's your ABI, models. Let me make sure we have our Newton soft. Type namespace models cannot be found. Looks like we have everything here. Looks like I'm missing this Unity models, using models, but for some reason that hasn't ever come up before. So let me see. Well, when in doubt, just Google it. It's probably something super simple. I forgot to include. Cannot be found in namespace either AG model, use namespace model, create model, always replace name model using the namespace, create model, code sample, choose namespace. All right. Unfortunately, it looks like I'm not going to be able to finish that minter. I'll have to check back at our scripts, but we were really close to actually finishing this. So I'll show you what the next steps are. So in order for you to get your wallet to work, for you to communicate between your script, that might actually be the issue. So in order for you to communicate between Godwoke and Minter, your IPFS, it's going to need to know what wallet are you signed into. So let's import our ChainSafe SDK and connect our wallet. All right, so let me go to my files. Looks like I don't have it open already. If you go to our documents, you'll see that I have the Unity SDK, the ChainSafe SDK link here. You can just click on this, download version 5. That's the one we're using for this demo. Once you've downloaded it here, you can drag and drop it into your project. So drag and drop. It's going to import the package. So these are all the details for the package. Import. All right, so we have additional scripts and everything we need from ChainSafe, including the login screen for our wallet. All right, so at this point, we should have everything set up. Let's see, metadata helper does not exist. Looks like we got rid of the other issue. So the problem was I did things a bit out of order. I was supposed to download the ChainSafe SDK first, import that, and that's what the models was referencing. Now we have this other issue in Godwoken. So metadata helper, that's, I believe, the script that we were working on. So let me go back. Metadata helper, so it's referencing this NFT, this file that we've created. Maybe I didn't spell it properly. Let's make sure we do that. All right. So it's looking to call that function. Let's rename this script to make sure that it's a one-to-one match. It's the utils here. Nope. Right-click, rename. And let's save that. All right, let's see. Metadata. Current context. Let's close this out. Let me take another second to look at our script. Helper, play prefs. This looks right. starts. Let's see. Yeah, at the end. So it looks like there's another issue here. As I mentioned, coding in front of everyone, it doesn't always go exactly perfect. If there are any issues here, I'll be updating these docs after the event so that you can go back, take a look at it, and make those changes that you need. But that was essentially the last step. We had our Godwoken Minter set up. We drag and drop the script into Godwoken Minter, and that's going to allow us to run the game and publish it online. So I can show you what the game kind of looks like without the script running yet. So give me 1 second just to show you that it'll actually show, online on your web browser. So let's instead, let's see. For now, just leave that blank so that it compiles. We don't run into any issues here, hopefully. All right, so this is going to allow us to run the game just so that we can test it, see that it runs in the browser. It'll interact with our wallet, but it's not actually going to mint on our blockchain because of that last script. There's a bug there that we'll need to rework. So when you're going to run your game, go into File, Build Settings. Here you're going to have a scene by default, but we want to remove that scene, so delete it. Our main scene for the game is the one we're looking at right now. So that's the free draw asset. We're going to want to switch this, if it's not already switched, to WebGL, because right now it's configured so that it'll run on your computer once you run the game. Let's switch platform to WebGL. Give it a second or two to convert. Next, we're going to have to change the resolution of the screen. If you played some high-performance games, you notice that your screen kind of wigs out from time to time. That's probably because your resolution settings aren't right. So let's go to Player Settings. Go to Resolution. Make sure you have Web3 GL clicked. And exit that. So now we have the Unity asset, but we need a way for us to log into our wallet, and that's provided by the ChainSafe SDK. So let's X this out. Go back to our project. So this is one scene, which is viewing the game, being able to draw the game. But we need to have another scene, which is the login menu. So whenever you're playing a game, that's usually the first thing that comes up. You're starting the game, and it transitions to another scene. So let's go over to WebGL templates, WebGL here. First thing we're going to have to do here is switch the network. So ChainSafe can interact with several different EVM-compatible chains. We're going to want to find where this is located and make sure we want it to communicate with our Godwoken blockchain. So show an Explorer here, and let's open with our editor. So when you're configuring this, it'll have like a list of different chains you can use. You see like Avalanche, Celo. But here, we're going to put in our Godwoken chain ID. So let's go back to our docs for our ID. It's 71401 here. Go to your script, replace that here. Save that, and now the ChainSafe SDK is now going to communicate with our Godwoken network. Let's cross that out. Now go to the templates that they provided for us. And you can find those templates by going to the Web3 Unity folder and then Scenes. So you have a wallet login, which is like if you're making a game that's on desktop, and then you have your web login, which is what we'll be using. We want to save all of our changes. So if you zoom out from here, it's a basic login menu. So this is the first scene that's going to load. You'll log in, and then it'll transition to the actual game. We want to add this scene to our build. So go to Build Settings, Add Open Scene. We want to make sure that this is the first thing that the user sees. So we want to drag and drop this to the top. And now we're all set to build and run. So let's build and run this. Let's save to a new folder. Let's call that new folder Builds. So new folder, Builds. Select that folder, and that's where we'll save every iteration that we make of this game. So this could take a decent amount to build the first time. If you have a pretty good computer, it could take 3 to 6 minutes. If you have a bad computer, it could take 20 minutes. If it's longer than that, then you need to upgrade your computer if you want to make games with Unity. So while this is going on, it might not take as long since it doesn't have the minter function. I want to go back to our presentation and discuss some more information about why NFTs. Hello. We've created some NFTs, and a lot of people don't necessarily know what is the real value of having NFTs in your game. So first, it's being able to track people's wallets and understand the history that they have with your game and also with other games. So let's say I build a game today, and 10 years down the line, I want to reward the first person to play my game. I can check their wallet and give them an airdrop, free tokens, to try to entice them to continue to be a member of our community, or it's just to reward them for being with us for over a decade. They may get a special item depending on how many years they've been with us, but it allows you to kind of grow your relationship with your customer to a level we've never really seen before. So not only can you do that, but other people who are interacting with your community can also do that. So let's say a friend builds a game and you want to kind of tap into a similar user base. You can check the smart contract that they use for their game, see all of the wallets that minted with that smart contract, and then you can reach out to those players. You can give them items for your game. This is also commonly used as what's called a vampire attack. Let's say you have a competitor. They've identified the target market. Let's say it's a race car game, and you're making another competitor race car game. You can see the exact audience that plays this, maybe even identify who are the most highly ranked players and invite them to your game through airdrops, through special rewards. So that's why we want to build NFTs, why we want to start incorporating them in games. You can also buy, sell, trade them. So you can take them out of the game, use them in several other games. So it's a way for people to get rewarded for the time they've invested into playing your game. Now, why would you want to build NFTs on Godwoken? So Godwoken is a blockchain focused on creatives and game developers. So first, we're the lowest gas fees for optimistic rollups. If you look right now, it costs on Loopring about a penny for you to send over Ethereum from one wallet to another. But for you to send over PCKB from one wallet to another, it's about 0.004 cents. So it's less than half a penny if you want to send over transactions. So hands down, the lowest fees. We have a rebalancing gas fee. So one Ethereum today, let's say 0.1, may be $100 today, but a year into the future, it may be $1,000. So even though you're processing the same transaction in the game, the actual dollar value could dramatically rise for games and for the players. So it makes it complicated to scale when the network gets congested and you have a game that costs now thousands of dollars for a player to make a move. So our gas fees rebalance according to USD. So if a transaction costs $1 today, no matter what the congestion is on the network, it'll cost $1 tomorrow, 10 years from now, whatever it is. We have a gasless API. So we noticed that when people want to play games, when they want to interact with NFTs, they don't necessarily understand what it is to acquire a testnet token. Well, not a testnet token, but the currency for that network, right? So we wanted a way for developers to absorb those costs and say, hey, if you want to play this game, you can jump in, play, claim an NFT without you having to process a transaction. So that's our gasless API. We have a Web2 sign-on that we're working with. So you don't have to go through the steps that we've gone through to sign up the same way people normally do for MetaMask. You can just sign up with your email or a Twitter login, your social networks. So the idea is we want to make it seamless for players to onboard, to make it into an experience that they're used to and comfortable with. We're also working on our fiat on-ramp. So sometimes it's a bit hard to bridge to layer 2. By offering a fiat on-ramp, you can just purchase the currency directly in the wallet, and you don't have to go through those additional steps. And as you've seen throughout the demonstration, we've used Ethereum compatible tools, Remix, Open Zeppelin, ChainSafe. So anything that you can do on Ethereum, you can pretty much do on us. So we wanted to make it something that's easily accessible for the developers who have the skills but are looking for something that's optimized for games and for creatives. So that's why we think you should work with Godwoken. Now, if you do decide to work with Godwoken, we have an incubator that we're running right now, and we offer development support. So if you need any help just working with our blockchain, we'll have a developer work with you side by side. We offer marketing support. So let's say you're ready to launch your dApp. We have our network. We host Twitter AMAs. We host Telegram AMAs to try to get your application out there. And if we think your game is going to bring a lot of people to our network, we'll even offer you a grant anywhere ranging from like $2,500 to $20,000 just to get you started and to have your game up and running. I actually manage the Build Club, so I review all of those applications. So if you want to talk to us after the event, if you have a game idea, let us know what you're working on, and let's see if we can collaborate. So now if you want to learn more about Godwoken, you can scan our link tree or go to godwoken.com. If you scan our link tree, you'll navigate to our Twitter account, our Discord community. It'll also have the links for Build Club. So if you're more interested in that process, it'll have links to our Twitter and our Discord. And finally, this is me, Jay Albert. This is my personal link tree. So if you want to connect afterwards, there's somebody during the presentation who came up who said they wanted to connect. You can scan my link tree, reach out to me on any platform. I'm pretty much always available to collaborate. So now let's check back on our game. It should be done by now. Looks like it's running a bit more. But generally, once the game finishes running, it'll automatically open up on your browser. And you'll see the same interface that we saw earlier today, which is your draw application, so you can draw whatever you want. Press the mint button. It'll save that asset onto IPFS, NFT storage. Once we fix the Godwoken minter, you'll be able to put that script together. And once you press that mint button, it'll actually mint on our blockchain, and you can preview what your NFTs look like. Let's skip ahead to that part. So there is a DAO right now on Godwoken blockchain called NFT Nation. This is the marketplace that they're working on. So if you want to preview your NFTs at a later time, you can access this website. I've provided the links in the docs as well. It's already set up, so you can connect your wallet, MetaMask, and sign on with your Godwoken wallet. It's currently in test phase, so if you do take a look at it, you have some feedback. The community is very interested in hearing what you have to say. But if you scroll to the bottom, we actually did this tutorial a few months ago, I want to say. And this was one of our users' drawings. So you can see it's the same exact kind of interface. They drew their asset. They were able to mint it. Some of the packages have upgraded since then, so that's why we ran into a bit of an issue. But that's essentially everything you need to know to be able to turn your Web2 asset into a Web3 game and mint on the Godwoken blockchain. I think it'll probably take a little bit longer, so I think it's a good time to wrap this up now. As I mentioned, my name is Jay Albert. I want to thank everyone for coming to the presentation. I'll be updating the documents after this meeting. So I'll be working through that bug, moving around certain components so that it's in a easier way to work through. And if you want to work with a Build Club, want to work with Godwoken, reach out to either me or Sam is also here. We have some gear at the front if you want. So come up after the event to grab some shirts, some stickers. Come talk to us and let us know what you're working on. Thank you.